This is the 5-1 to 5-2 review. Calculators are allowed, and it's number 14, which is a free response problem. And what I have here is going to look a little different because I copied this picture over and over and over so that we can do each one separately. Part A, we want a left-hand Riemann sum with n equals 4 to accumulate from 0 to 8. So left hand, first of all, we can figure out that our delta x will be b minus a over n, which gives us 2. So I will be cutting here, 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 and here. And I want a left sum. So left would give us a height that comes from 0, height that comes from 2, a height that comes from 4, and a height that comes from 6. So here at the 0, we can see that we get a rectangle that is 8. Here we get a 0 out, so we get a rectangle whose area is 0. Here we're going to have a negative accumulation, which will be a negative 2 times 2. And then here we get 0 again. So we end up with a result of 4. Next one, part B, and that's 1 point for that answer, by the way. Next one, part B, we want a right-hand Riemann sum. So same thing, except now we use the y-coordinates that come from the right. So this one, the right, is 0. Here the right gives me that negative 2. Here the right gives me 0. And here the right gives me 2. So in this case, I end up with 0 minus 4 plus 0 plus 4. So I end up with 0. For part C, I want to find exact values of this integral. So I'm no longer approximating with rectangles. I'm now going to use areas of these shapes. So I want to accumulate from 0 to 4. We can see that I have a triangle and a quarter of a circle. So the triangle is a 1/2 times a base of 2 and a height of 4, and that's a positive accumulation. Then I'm going to subtract the quarter of the pi times the radius, which is 2 squared. So I end up with 4 minus a pi. Next one, D. I want to use areas again to find the exact value, only this time I'm accumulating from 2 until 8. So in this case, I have a half circle that's underneath, so that's a negative accumulation, and then a triangle on top. So I'll have a negative 1/2 of that pi r squared plus the positive accumulation. I end up with, it looks like, negative 2 pi plus 2. And each of these so far have been 1 point. So now we move to our part E, which is we want to use properties of definite integrals to find the exact value. So we have the integral from 1 to 5, and then we're going to subtract the integral from 4 to 5. So that means we're going to end up with the integral from 1 to 4. We'll see that we have this and this. So that'll be a 1/2 base times a height minus a 1/2, or excuse me, that's a fourth of a triangle, fourth of a circle, pi times a radius squared. Now what I'm going to need to see here, because it says we are to use the properties of the definite integrals, I can see that we have an answer of a 1 minus pi, but I'm going to need to see that you've used these. So what I would want is that 1 to 5 f of x dx plus a 5 to 4. We can flip those two limits and change the sign, and then we can see that the 5's will cancel. We'll get that accumulation from 1 to 4. So I need something written down about this. That's one of your points. And then your final answer, which is your next point. Okay, if we look at part F, which is the last one, again we're using properties of definite integrals. So I need to see those properties put into play. So the first one is I want you to separate the two integrals and distribute that constant. Because now from 1 to 7 we can accumulate, and then we need to double it. So we'll have 2 times that accumulation, which is a 1/2 base times height minus half of a circle with a radius of 2 plus this next little triangle. And then we're going to subtract 2 times the antiderivative of 3, or we can remember that constants integrate back out as the constant times the length of the interval, because we have a rectangle accumulation under that 3. So if I multiply this all out, I end up with a 33 that's negative minus a 4 pi. So the point breakdown on this one is you get 1 point for separating the interval so that the constant is pulled out separately, get another point for distributing the 2, and then you get a point for your answer.